Assalamu alaikum wa rahmatullahi wa barakatuh. All my dear students of class 8, once again welcome back to your chemistry online class. Today I am starting with the revision of lesson number 8, water. I had taught you that how much of the earth's surface is covered with earth and what is the forms in which water occurs on earth. We all know that earth is covered by 2/3 amount by water. That is, it is one of the most essential substance for life, and all living beings are dependent on water. So I told you that about 70%, that is 2/3 of the earth's surface, is covered with water, and that is amounting to, or the forms in which it occurs is ocean, winds, waves, currents, tides, etc. Then you have been told so many times that water is present in all the three states of matter, that is in the form of solid, in liquid and gas. That is, in solid state it exists as ice, snow, frost, and in the liquid state it occurs as rivers, water, ocean, then lakes, ponds, and so on. And then in the form of gas it occurs as water vapor, clouds, mist, right? So water is present in all the living matter, plants, animals and human beings, and the weight of ours, that is 70% of our weight, is water. It is present in all fruits and vegetable, and it is also present in the things that appear dry otherwise, but when you burn them you see that the water vapor has evaporated from them. And what is the importance of water? It is used for bathing, drinking, cleaning, cooking. Then it is essential for the growth and development of the living beings. It regulates the body temperature by sweating. Then it is used for growing crops. It is a habitat for some living organism. It acts as a coolant in nuclear reactors. It is used in laboratories to do experiments and many such uses, isn't it? Then what are the different sources of water? Then there are three main sources of water, that is rainwater, surface water and underground water. Rainwater, it is the purest form of natural water. And how do we get rain? That is, we get rainwater from where? From rain, that from precipitation or rain. So we all know the water cycle and how the rain is formed, that it is formed by continuous evaporation and condensation process. The evaporation and condensation process in the atmosphere, and it contains dissolved gases like oxygen and carbon dioxide. And apart from this, this rainwater is also source for enriching the water table, and it is a source of underground water. So the first shower of rain collects dust and germs present in the atmosphere, so we should not take shower in it. The next source of water is surface water. What is surface water? That is the water present on the surface of the earth in the form of river and lake, in the form of ocean and seas. So river and lake water, this also, how does it come? It comes from the water that has been collected through rain or by the melting of snow on the mountains, and this water descends down the mountains and goes into the rivers, and when while reaching the rivers it also dissolves some soluble salts and certain suspended impurities like sand, clay and twigs, and it also contains waste materials that are discharged into rivers by factories. They may also contain germ, which may be a source of various diseases like jaundice, dysentery, cholera and typhoid. That is why these diseases are known as waterborne diseases. Therefore, river water cannot be used for drinking purposes directly because it carries many germs. Then this ocean and sea water is the largest source of water on earth, and they contain a large amount of what? They contain dissolved salts. That is why this water is salty and also called as saline. So it is not fit for drinking and irrigation because of its saline nature. Then the underground water or the subsoil water. It is a reservoir of water collected over the hard non-porous rocks, that is the rocks which through which water cannot seep through, and below the surface of the earth. This is called the groundwater or underground water, and the level of groundwater is called as the water table. You can see this is the level of groundwater. This is called as the water table. This is the level, right? Not this. This is the water table, and groundwater is pumped out by digging wells or by use of hand pumps and tube wells. And this groundwater is used for household, agriculture and industrial purposes. Is that clear? So springs are also a source of underground water, and this water contains dissolved impurities, but they do not contain any suspended impurities of germs. So this water is rich in minerals with the medicinal properties, and at times it is used for curing many diseases. Is that clear? So this has a therapeutic value, means has healing properties also because of the presence of certain minerals. Then what is water cycle? So the continuous movement of water from the earth's surface and water bodies in the form of water vapor to the atmosphere, and from the atmosphere back to the earth's surface. This is called rain, hail or snow, is called as water cycle. So in other words, you can say that is the continuous process by which water moves from earth's surface to the atmosphere and back, passing through the living and non-living parts of the environment. Is that clear? So this is the cycle which maintains the continuous supply of water on earth, and apart from this, it also regulates weather on earth. The three main processes that are involved in water cycle are evaporation, condensation and precipitation. Is it clear? So what is evaporation? When the water is heated, whether be it the water of the river, ocean, lakes, ponds, anything, it evaporates from the water bodies. And then plants also give out water vapor through transpiration. Transpiration is the loss of water vapor through the aerial parts of the plant, basically the leaves and sometimes the stems also. So water vapor are all continuously being added to the atmosphere by the process of respiration by animal and plants. That is you remember the reaction, the equation of respiration and the burning of fuels. So by these processes, the water is being added to the atmosphere. Another process is condensation. That is what is happening, that at high altitudes the air becomes cold. Here the air becomes cold at high altitudes. At height, when the warm air rises up, it is rising up, and on reaching certain level it condenses. When the air becomes cold, the water vapor present in air condenses. As you take a glass of water, hot water, and then when it cools down, you can see water droplets on the sides of the glass, all around the glass. So this is because of condensation. Similar process is happening when the water vapor present in air condenses to form tiny droplets of water. These water droplets, along with dust particle, they form clouds. Is that clear? And the tiny water droplets in clouds come closer and form big water droplets. Then the precipitation takes place, that is water from the clouds fall as rain, hail or snow, depending on the altitude and also depending upon the temperature at that particular place. So this is called as precipitation. The rainwater collects in seas, ocean, rivers, lakes and ponds. Is that clear? And this cycle continues, and that is how there is been maintenance of the regular supply of water on land. Now we all know that molecular formula of water is H2O, isn't it? And how it is formed? You can see it has been formed by the sharing of electrons, and the molecular mass of water is 18 AMU, and it was Henry Cavendish who proved that water is a compound made up of hydrogen and oxygen, and later it was supported by Lavoisier. So you can see that one molecule of water contains 2 atoms of hydrogen and 1 atom of oxygen. And the ratio of hydrogen, oxygen and water is always 1:8. Is it clear? It is 1:8. And this is split up. Water cannot be split up easily by using any chemical or by any other physical means. It can be split up by electrolysis, that is when electric current is passed through it. And I have shown you when the process by which water is electrolyzed and the apparatus that is used, and water is collected by the process of electrolysis, that is when electric current is passed through it, water is decomposed into its constituents, that is constituent element oxygen and hydrogen. And both the gases identified by the respective test, and hydrogen burns with a pop sound. And what is the confirmatory test for the presence of oxygen gas? That is a glowing splinter burns into a flame in hydrogen. So these two are the confirmatory tests for hydrogen. Now this pure water is a colorless, tasteless, odorless and transparent liquid. We all know this, and the boiling point of pure water is 100 degrees Celsius. It is 100 degrees Celsius, and the freezing point is 0 degrees Celsius at 1 atmosphere or 760 mm of Hg. And change in pressure and addition of impurities affect the boiling point of water. So when we add any non-volatile impurities or salts, non-volatile means which are not changed into vapors, the boiling point increases, and pressure is increased, the boiling point also increases. That is why it is easier to cook food in a pressure cooker than in an open vessel. So it is because when the pressure increases in the pressure cooker, the boiling point will also be increased. Is that clear? Similarly, with the freezing point also, the freezing point of pure water is 0 degrees Celsius and under normal pressure of 1 atmosphere. And change in pressure and addition of impurities affect the freezing point of water, and when pressure increases, the freezing point decreases, and when pressure decreases, then the freezing point increases. And when impurities like salt are added to water, its freezing point decreases. Then the density of water is 1 gram per cc. Is that clear? At 4 degrees Celsius. Water has a maximum density and minimum volume at 4 degrees Celsius, and the density of pure water at this temperature is 1 gram per cc. Is that clear? That is 1 gram per centimeter cube. Is it clear? Then pure water is a bad conductor of heat and electricity. That is why we have to add an acid to it in order to make it a good conductor of electricity when doing electrolysis. So water conducts electricity only when some impurities like salts or gases are present in it. Then the specific heat of water. The amount of heat required to increase the temperature of a unit mass of a substance by 1 degree Celsius is called the specific heat of that substance. And the specific heat of water is high, and for this reason it needs more time to lose heat or to become cold, or and water neither heats up nor cools down quickly. That is why it is used an excellent cooling agent, because of its high specific heat, and it is used as coolant in car engines, nuclear reactors and machines. It absorbs heat and prevents overheating. Anomalous expansion of water, that is, we all know that when liquids are heated, they expand, and when cool, they contract. But water behaves exceptionally differently. It has an exceptional behavior. That is, when water is cooled from 4 degree to 0 degrees Celsius, then what happens? It becomes less dense, it expands, and due to this expansion, the volume water increases and the density decreases. Is that clear? And this has a particular this importance in the ecosystem, that when water is heated from 0 degree to 4 degrees Celsius, it contracts. instead of expanding, and due to this contraction its volume decreases and density increases. And when we further heat water above 4 degrees Celsius, it expands like other liquids, that is volume increases and density decreases like other liquids. So, we can sum up and say this, that it is found that water has minimum volume and maximum density at 4 degrees Celsius, and the expansion of water when it is cooled from 4 to 0 degree is called anomalous expansion of water. So, the anomalous expansion of water helps the aquatic animals to survive in cold conditions. Just because what happens in winters, when the temperature falls below 0 degrees Celsius, the water bodies like lakes, ponds and rivers freeze at the top, whereas the water below the ice remains at 4 degrees Celsius, and this is particularly useful for the existence of the living organisms. So, the temperature of water on the surface of water bodies decreases, and because of this water starts contracting and its density increases. The cold water sinks to the bottom of the lakes and ponds, and this will continue till the temperature reaches 4 degrees Celsius. And once the temperature has reached 4 degrees Celsius, the temperature will continue to fall below this, but water expands due to anomalous expansion, and its density decreases, and hence what will happen, instead of sinking, it will keep the sheet of ice will keep on floating, and below that the water will still be at 4 degrees Celsius, and water and the living organism can easily survive in such conditions. So, the lake freezes at the top, but the water below the layer of ice remains at 4 degrees Celsius. Since ice is a poor conductor of heat, it does not allow the flow of heat from the water in the atmosphere. Is that clear? That the temperature of water in the water bodies remains at 4 degrees Celsius, and this is helpful for the aquatic plants and animals both to survive. Is that clear? Under such cold conditions. Now, we all know that water is a universal solvent. Why do we call it a universal solvent? Just because it is capable of dissolving a variety of different substances. So, it is called a universal solvent. It can dissolve many solids, liquids and gases in it. So, it is also called as the universal solvent. Now, in this respect, we have certain different terms, that is solution, that is a homogeneous mixture of a solute and a solvent. Then a solute, a substance that dissolves in other substance to form solution, is called a solute. For example, salt and sugar when dissolved in water, then salt and sugar are called as the solute and water is called the solvent. That is a substance in which the solute is dissolved to form a solution. Is that clear? Then a solution in which solute is dissolved in water is called an aqueous solution, and the solution that are made in solvent other than water like alcohol and carbon tetrachloride are called as non-aqueous solution. Then liquids that dissolve completely in each other and form a single layer are called as miscible liquids. For example, fruit juice dissolved in water. Is that clear? They are called as miscible liquids. Then immiscible, they form separate layers like oil and water, glycerine and water. When they are mixed together, they form separate layers. And even gases like oxygen, carbon dioxide and ammonia, they also dissolve in water. Then we have saturated, unsaturated and supersaturated solutions. So, the composition of solute and solvent varies in a solution. For example, a solution in which more solute can be dissolved in a solvent at a particular temperature, it is called as an unsaturated solution. More solute can dissolve. And a solution in which no more solute can be dissolved at a particular temperature, it is called a saturated solution. Similarly, a solution that can contain more solute than it can hold at a particular temperature is called supersaturated solution. That is, when you cool such a kind of solution, on cooling it forms crystals of the extra solute that has been dissolved. Is that clear? Then what is solubility? What is solubility? That is the maximum amount of solute that can be dissolved in 100 grams of a solvent to form a saturated solution at a particular temperature and pressure. Is that clear? So we have different substances which have different solubilities. For example, at the same temperature, sugar will be having a different solubility, that is, amount of sugar that will be needed to be dissolved at that temperature will be different. And for example, copper sulfate, the solubility is 204 grams, and sugar is 204 gram, and of copper sulfate is 21 grams at 20 degrees Celsius in 100 grams of water. And substances that are not soluble or they have negligible solubility in a solvent, they are said to be insoluble. Then as certain factors which affect the solubility, for example, the solubility of most of the solids in liquids increases with increase in temperature. For example, you keep on dissolving sugar, and as soon as the particular solution becomes saturated at a normal temperature, but once you increase the temperature, the solubility of sugar will increase. It will become supersaturated solution. Similarly, the pressure, the change in pressure does not affect the solubility of solids and liquids, whereas the solubility of gases and liquids increase with increase in pressure and decrease with decrease in pressure. Is it clear? Decreases with the decrease in pressure. Then the size of solute particles. The smaller the size of the solute particles, greater will be its solubility. And the stirring brings most of the solvent in contact with the solute and hence increases the solubility. Once you stir a particular solute in a solvent, the solubility will increase, and the time that will be taken for a particular solute to be soluble in that solvent, that will also decrease. What is the importance of dissolved solid substances in water? That is, there are certain gases like oxygen and carbon dioxide which are useful for the aquatic plants and animals respectively. Is that clear? That is, the oxygen that is dissolved is needed by the aquatic plants as well as animals for respiration, and the carbon dioxide that is dissolved in water, that is used by aquatic green plants to make their food by the process of photosynthesis. And all other minerals that are dissolved in water are necessary for the growth of the living organisms. Apart from this, these dissolved minerals also impart taste to water. Is it clear? Then there are terms like solutions, suspensions, and then we have the emulsions. Colloids. What are solutions? For example, you have the homogeneous mixtures in which the size of the solute particle is less than 10 to the power of minus 7 centimeter. They are called as true solution. And these the particle size is so small that you cannot even make out the size with the help of the simple microscope. Therefore, we cannot differentiate between the solute and the solvent. For example, once you dissolve sugar or salt in water, or any solute which is soluble in a particular solvent, you cannot make out the size of the solute. It is called a true solution. Then colloid, the heterogeneous mixture with the size of the solute particle is in between 10 to the power of minus 7 to 10 to the power of minus 4 centimeter. Is 10 to the power of minus 7 to 10 to the power of 4 centimeter, or in other words you can say 1 to 1000 nanometer. They are called as colloids. Is it clear? They are called as colloids. And for example, gum, milk, then toothpaste, shampoo, hair setting gel, all are example of colloids. And suspensions, they are the heterogeneous mixtures in which the size of the solute particle is greater than 10 to the power of minus 4 centimeter or 1000 nanometer, are called suspension. For example, chalk in water, mud in water, flour in water, they are all example of suspension. You can easily make out that the particles are floating in the water. You can easily identify the size of the particles. So this is all for today. Please revise properly. Allah Hafiz.